In this video, we'll be once again attaching squares to a region described. This region described is going to be y equals negative 3x plus 4. So I'll have a function up here at the value of 4, 0, comma 4, and I'll go ahead and graph a declining line here. In this location, again, we're going to go ahead and have the x-axis and the y-axis as both regions, and then the idea is to attach squares parallel to the x-axis this time. So the difference between this one and the previous example is that our squares will be attached in this direction. So that means we're going to have some object coming out of this space here. And every time that I go ahead and graph this, it's going to be a, again, larger square going in this direction, and it'll be a smaller square going in this direction. So slowly and slowly these squares will get tinier and tinier. So based on the fact that all these squares are again sliced with y, okay, that means my integral is going to be the area function in regards to y. So my y is going to start off at 0 because that's the lowest y value I can possibly pick, and I'm going to go all the way up to the y value of 4. That's the highest y value I could possibly pick. My next step here is to determine the function that's on top. And you'll notice if I'm cutting this function, again, I'm cutting it in terms of y. If I'm cutting it in terms of y, I must go from the positive side of x over here to the negative side of x over here, which tells me that this function right here is the function that's on top. So I'm going to have to take that function, which again was y equals negative 3x plus 4, and I'm going to have to solve that for x equals. The second detail that's important about this is the fact that I need to figure out what my area function is. Well, since I'm attaching squares, the area formula is, again, s squared. So this length right here is s, and this length right here is s, and it's, again, going to change based on whatever this function is. So down here, this s distance is going to be different than this s distance over here, but the formula for finding the area of that square is going to be the same as finding the formula of this square over here. So I'm going to go ahead and take this equation, I'm going to solve it for x equals, which is going to provide me with x minus 4 all divided by a negative 3. I'm going to go ahead and use that as my s value, because again, the distance from here to here is an x value, and that x value is representative of that function. So my area formula, my volume will end up being equal to y equals from 0 to 4 of my area function. My area function, again, is this thing squared. But this thing squared is representing the s, which is the x distance in this problem, which is simply this. So I'm simply going to have y minus 4 divided by 3 quantity squared dy. Again, this is the function from the region. The squared is the formula for the area of the object that I'm attaching. At this point, we're going to go ahead and simplify as much as possible. I'm going to factor out a 3 squared in the denominator, which is 1/9. And I'll have y equals 0 to 4 of, y minus 4 quantity squared is simply y squared minus 8y and then plus 16 dy. At this point, again, this is simply integration, which I can let you finish on your own.